Hi boys and girls, welcome back. This is grade 4, lesson 8.5, comparison problems with fractions. And yes, this is our problem solving unit. So let's get right into it. We have solved problems involving comparing and multiplication in the past. Here is a comparison problem with multiplication about supplies that might be on my desk. So I'd like you to think about what we've done in the past and how we've used bar models to help us make comparison statements. Let's take a look. All right, here's our problem. Mrs. Kennedy has 6 pens in her desk drawer. There are 4 times as many pencils as pens. How many pencils are in the desk drawer? Well, let's take a look at this problem. There are some words that should be familiar to you, so let's go back and find out what we know for sure. Well, first of all, we know that Mrs. Kennedy has 6 pens in her desk drawer. Oh, look at this. She has 4 times as many as pencils as pens. How many pencils are in the drawer? I'm hoping that this begins to ring a bell for you. We're going to go ahead and create a bar model to show the comparison. So let's get right to it. So I've begun to create the model. So far I know that Mrs. Kennedy has 6 pens in her drawer. So I have my bar model. I've created a box with 6. And I know that there are 4 times as many pencils. So the pencils bar that I'm making has to have 1, 2, 3, 4 equal places. All right, now no laughing. You know I'm trying to make these equal. So I know that there are 1, 2, 3, 4 times as many pencils as pens. So this is 6, this is 6, this would be 6, and this would be 6. What I'm trying to find out, boys and girls, is the value of n. Because n will tell me how many pencils they will tell me how many pencils are in the desk drawer. So looking at my model, how many pencils does Mrs. Kennedy have in her pencil drawer? Let's take a look. If you said 4 times 6 equals 24, there are 24 pencils in Mrs. Kennedy's desk. You are absolutely correct. And that's exactly what my model showed. So I'm going to ask you to use this method, boys and girls, this method representing multiplication and a bar model, and we're going to try and solve some problems in the next few moments. So let's take a look at another word problem. All right, here's our word problem. The deepest part of the Grand Canyon is about 1 1/6 miles deep. The deepest part of the ocean is located in the Mariana Trench in the Pacific Ocean. The deepest part of the ocean is almost 6 times as deep as the deepest part of the Grand Canyon. About how deep is the deepest part of the ocean? Great question. So let's go back right now and figure out, what do I need to find? All right, boys and girls, you're right. What I need to find is about how deep is the deepest part of the ocean. That's my question. What information do I need to use? Well, let's see. Let me go back into the problem. I know that the deepest part of the Grand Canyon is about 1 1/2 miles deep. 1 1/6. That's about as deep as it goes, about 1 1/6 miles deep, and that's the deepest part of the Grand Canyon. Then it tells me the deepest part of the ocean is located in the Mariana Trenches in the Pacific Ocean. The deepest part is almost 6 times as deep as the deepest part of the Grand Canyon. Now, how will I use this information? Well, because we're using models in this lesson, we're going to go ahead and draw a model. This time we're going to draw a bar model. So let's go ahead and get started. Here's the bar model. Our Grand Canyon depth represents 1 1/6 miles. We know that the ocean in the Mariana Trenches is 1, 2, 3, 4, 5, 6 times as much as the Grand Canyon. What we're going to try and do is solve for m. So the first thing we want to think about is how are we going to write an equation and solve it? M will represent the deepest part of, yes, the ocean in miles. So M will represent what? 6 times 1 1/6. So we have to look at our multiplication problem here and say, we have a whole number times a mixed number. We've done that. We've got this. We're going to convert 1 1/6 to, you're right, 7/6. 6 times 7/6. Let's take a look. Now we're going to go ahead and multiply our whole number times our fraction, and M is going to equal 6 times 7 is 42, and of course our fraction denominator stays the same. So 42 over 6. Now we're going to simplify. M equals, well, how many 6's are in 42? You're right, 7. So M must be 7. So the deepest part of the ocean is about 7 miles deep. Good job, boys and girls. About 7 miles, deep. Good job. Let's try another. Here's another word problem for us to work with. All right, so boys and girls, let's go ahead and read it. So it says, mountains are often measured by the distance they rise above sea level. Mount Washington rises more than 1 1/10 miles above sea level. Mount Everest rises about 5 times as high. About how many miles above sea level does Mount Everest rise? All right, good problem. Let's see if we can come up with our answers now. I'm going to go right back into the problem and I'm going to go answer my questions. What do I need to find? Well, I need to find about how many miles above sea level does Mount Everest rise? Now, what information am I going to use to help me find this? Well, the first thing I'm going to say is I know that Mount Washington rises more than 1 1/10 miles above sea level. The other thing that's going to help me is I know that Mount Everest rises about 5 times as high. So it sounds like I'm going to be comparing the height of Mount Washington to Mount Everest. What will I use, or how will I use this information? Well, of course, we're using models. So boys and girls, I'm going to ask you to draw a diagram to compare the heights of the mountains. Let's see how well we can do. All right, so let's see if we have this. Mount Washington is 1. Oh, that's what's horrible. Let's try that again. Okay. It rises 1. Hello, come on. We got to get this up here. 1 1/10 miles above sea level. I know that Mount Everest rises 1, 2, 3, 4, 5 times as high. So this is the height of Mount Everest. If h is the height of Mount Everest in miles, h must equal what in a number sentence? Let's take a look. H equals 5 times 1 1/10. All right, so how are we going to solve this? I've done multiplying of whole numbers times mixed numbers. So let's see if we can figure this out. H equals 5 times, I'm going to convert my 1 1/10 to a fraction greater than 1. 11/10. Then I'm going to go ahead and multiply. H equals 5 times 11 is 55/10. Now, that is a fraction greater than 1. So what I'm going to want to do is convert that and think, how many tens are in 55? So let's go ahead and convert my fraction greater than 1 whole and see what we can come up with. Yes, there are 5 tens in 55 with 5/10 left over. Or, in simplest form, boys and girls, 5 and 5/10 can be 5 and 1/2 miles. So the height of Mount Everest is about 5.5 miles above sea level. Wow, that's pretty good. All right, boys and girls, I think we're ready for you to try something. Here is the practice problem that I would like you to work on tonight. You're going to create the bar model and solve for the following. You run 1 3/4 miles each day. Your mom runs 4 times as far as you do, and no laughing. How far does your mom run each day? So tomorrow I will look forward to seeing how you have solved this word problem using a bar model to help you compare how far you run and how far your mom runs each day. Enjoy, thank you, and we'll see you tomorrow.